Hey guys, welcome back. Today we will start organic chemistry. I will just tell you about the basics. It might be a bit of a long video, but it's important that you know these things. So starting with definitions, the first is hydrocarbons. It is the main one in organic chemistry. It is the CH bonds. CH compounds are hydrocarbons. Hydro for the hydrogen, carbons for the carbon. This is an example. And then you have cyclic compounds now, which are like they have a shape, a closed structure, for example a pentagon. All right, so we can have two types. So we have carbocyclic and then heterocyclic. Carbocyclic is when the structure only contains carbons. Heterocyclic is when there is another atom, and these are mainly nitrogen, sulfur, or oxygen. Then you have something known as heteroatoms. Okay, so these are any other element attached to carbons other than carbon. All right, so again, the most common ones are nitrogen, sulfur, and oxygen. All right, now let's speak about different groups of hydrocarbons. Starting with alkanes, they end with ane, as per the name, and the general formula is CaH2n plus 2. Alright, so there are 5 basic ones that you need to know, and if you know more, obviously it's better, but you need to know from C1, 2, 3, 4, and 5. And then knowing the number just by C, you can calculate H. So if it is C1, H will be 4. You're not going to write C1, you usually write it as CH4. C2 will be H6, C3 H8, C4 H10, and C5 H12, right? So 2 times the number of carbons plus 2. All right, now the names. So CH4 is known as methane. You need to remember meth, that is for C1, and ane is the ending for an alkane. Okay, C2 is ethane. Remember ane and F. C3 is propane, C4 is butane, and C5 is pentane. Moving on to our second group, alkene, ending with ene, and the general formula is CnH2n. C1 is not possible because an alkene is a functional group which is a C double bond C. So a double bond between 2 C's is going to give you an alkene. So this is why you cannot have one C. So starting with C2, 3, 4, and 5. All right, now trying to calculate the H. So C2H4, C3H6, C4H8, and C5H10. Now remember the names from the alkanes. So we have ethene, propene, butene, pentene. I'm stressing on the ene. If you have an oral exam, she asks you to draw an alkene, and she says propene and you draw propane. Or, she shows you a structure and she tells you to name it, and instead of ane, you say ene, or instead of ene, you say ane, then it's a bit problematic. And our last group is alkynes, and they end with ine, and the general formula is CnH2n minus 2. Okay, so this functional group is a triple bond. So C, triple bond, C. So obviously with C1, it is not possible again, starting with C2, 3, 4, 5. But it is not very common. Questions on alkynes, they are like higher chemistry questions. So we'll just stick with ethyne, which is C2H2. And this is what the structure looks like. Now we will move on to non-hydrocarbons. So we have alcohols, starting with them. So they end with ol, and the functional group looks like this, OH. All right, so starting again with C1, we can have or C2 or C3. So this is how you draw it. For methane, you have CH3 and OH. For ethane, you have C2, H5OH. For propane, you have C3H7OH. But what are the names? So methane will be methanol. It is methan. Why? Because it is an alkane, right? So it's methanol. Ethanol. Propanol. The O is important, and the an is also important because it is an alkane. So if it was an alkene, it would be propanol, butanol. All right, now carbonyl compounds. So there are three of them. One is aldehydes, then ketones, and carboxylic acid. They're quite important. An aldehyde looks like this, CHO. A ketone is C between the molecule, not at the end like aldehydes, but in between with a double bond O. And a carboxylic acid is a C double bond O with an OH, like an alcohol. Okay, so the carbonyl group is a C double bond O group. Let's look at each of them individually. So aldehydes, they end with al, Al, and as I told you, it's CHO. It's a C double bond O with a C attached to a hydrogen. So if we have C1, it's going to be HCHO. For C2, it will be H4O. So what are the names? It's methanol, but it's most commonly known in your question exams as formaldehyde. Formaldehyde. C2 is ethanol or acetaldehyde. Acetaldehyde. Then you have propanol, butanol. Okay, moving on to ketones. They end with one, O-N-E, and they are C double bond O in between the compound. All right, so we cannot have it with C1 because it's on its own. We also cannot have it with C2 because it will not be in the center, it will be in the ends, right? So we start with C3. So CH3, C double bond O, CH3, this is known as propanol. Then you have butanon, pentanon, hexanon. All right, now the third and final group of carbonyl compounds is the carboxylic acid. It ends with oic acid and looks like this, C double bond O with OH. All right, so we can start with C1, HC double OH, and so on. Okay, so the first one is methanoic acid, or more commonly known as formic acid. The second one, C2, is ethanoic acid, but it is the most common compound given in your exams, and it is named as acetic acid. Then you have propanoic acid, butanoic acid, pentanoic acid, and so on. Our next one is ether, and it is written as ether as well. It ends with that, and it is an alkyl group bonded with an oxygen and another alkyl group, right? So R is one alkyl group, R1 is another alkyl group. So for example, if I have CH3, CH2O, CH2, CH3, it is going to be diethyl ether, right? Because we have two ethyl molecules on either side, so diethyl and then ether. All right, moving on to amines and amides. They are two different things. Sometimes people confuse them, and so I will explain them to you together. So they are to do with the nitrogen atom, and amines are NH2s, or simply nitrogen attached to a hydrocarbon. Amides are the nitrogen atom attached to a carbonyl group. That is the difference. So if I have compounds with NH2 ending, so it will be methyl amine if it's C1, C2 ethyl amine. Alright, you're probably wondering, why am I writing CH3 and NH2 and not CH4? Because that's methane, right? Because a carbon can only have 4 bonds. And if I add CH4 NH2, that will be 5 bonds. So that is not possible. Instead, the amine group substitutes for one of the hydrogens. If I have an amide, it will be propanamide. Ethanamide. Okay, next is esters. For now, you only need to know that they end with O8 and they look like this. So you have a carbonyl group attached with an oxygen to an alkyl group, and that oxygen is from an alcohol. Okay, so a carboxylic acid and an alcohol will give you an ester. That's all you need to know, and this is an ester bond. Alright, next is anhydrides. Anhydrides are two carboxylic acids coming together forming a bond, an anhydride bond. So you have two carbonyl groups attached with an oxygen. And if I add an alkyl group, for example, let's just add methyl, CH3CH3, this will be known as acetic anhydride because we have C2 and an anhydride bond. Okay, now I want to speak about classification. Okay, so if a carbon is at the end of a chain or it's attached to only one carbon, it is known as a primary carbon. Okay, if the carbon is attached to two carbons, it is known as a secondary carbon. Or if it's attached to three carbons, it is known as a tertiary carbon. Okay, so this is important for you to know, and I'll explain why in another video. The same goes for alcohols and amines. So you have primary alcohols, primary amines, secondary alcohols, secondary amines, tertiary alcohols, and tertiary amines. And this is how they will look. So if I have a primary alcohol, the OH will be attached at the end of the chain, attached to only one carbon. Remember this. There is a difference between the OH being attached to two carbons or a carbon attached to two carbons. I hope you're understanding what I'm trying to say. So a secondary alcohol will be an hydroxyl group attached to one carbon, which is attached to two carbons. All right, and the same with amines. A tertiary will be a hydroxyl group or an amine group attached to one carbon that is attached to three carbons. Okay, what's important here is for you to know that a primary alcohol can be oxidized to an aldehyde. And upon further oxidation, an aldehyde can be oxidized to an carboxylic acid. Okay, a secondary alcohol can be oxidized to a ketone. Upon further oxidation, there is no reaction unless you increase the pressure and temperature really high, then it can become a carboxylic acid. A tertiary alcohol produces no product on oxidation, and this is a test used to differentiate between primary, secondary, and tertiary alcohols. Okay, on to the second part of our video, naming organic compounds. So, in order to name them, you need to remember two things. One is that a carbon-carbon double bond makes you start counting from the carbon initiating the double bond. Okay, and another thing is functional groups. So when you have a functional group, you will start counting from that carbon. Okay, keeping this in mind, let's start. So you already know our C1s to 5s, methane, ethane, propane, butane, pentane. So I'm gonna give you a compound and we're gonna try to work it out together. So here is the compound, and we can see, number one, there are no functional groups. Okay, perfect, easy, right? Second, there are no side chains either. I'll explain about the side chains later, but for now, it's just a straight chain, which is one of the easiest, to be honest. Okay, so we have 4 carbons, and we see no double bonds, so which one is it? It is a butane. Alright, here's another compound. So we see that we have no functional group, really, but we have a side chain. Okay, so this side chain is important because it changes the direction in which we count. And you always need to remember that the longest chain is the way to go forward with naming these compounds. So you have to pick out the longest chain. So let's see, this is 1, 2, 3, 4. Okay, then you have 1, 2, 3, No, that is short. So we have to go with the 1, 2, 3, 4 chain. Okay? All right, now once we have our chain, we will name it. So what is this chain? It is C4 carbon. So we're going to write butane. Butane, why? Because there are no double bonds. It's an alkane. Okay, now we need to choose the direction in which we have to start, whether we want to start from the right or from the left. I'm going to say let's start from the right. Why? Because the side chain is closest to the right, and this is what we want. Okay, so let's start. So we have already written our butane, which is the longest chain, and then you have the functional group. The side chain is a methyl group. So it is at which number? It is at the second carbon, right? So we'll write 2-methyl butane. If we had to start from the other side, we would have to say 3-methyl butane, but it's better to say 2-methyl butane. This is why we count from the right side. Now I'm going to give you some side chains that that are common in the exam. So you have methyl, you have ethyl, and propyl. These are the alkanes that we deal with just one hydrogen less. Okay? Okay, let's move on to a new compound. Oh, so here we have a double bond. Okay, so that's our functional group. And we also have a second functional group. So hydroxyl group, which is an alcohol. So write that down first. Functional groups, 2 of them. Okay, now which side do we start first? The functional group, the hydroxide ion, is more important than the double bond. So we start from the right side again. So this is the longest chain is 4, again, butane, but there is a double bond, so butane. Okay, and the hydroxyl group is on the first carbon, so butane 1-ol, and the number 3, why? To say where is the double bond. So it is on the third carbon, so 3-butane 1-ol. This is benzene, a very important structure for chemistry, and you can either draw it like this or like this. You can see from inorganic chemistry that it is a conjugated system, right? Alternating double bonds. And hence, what effect does it have? It has a resonance effect or a mesomeric effect. All right, now let's use an example with benzene. So this is a structure and we have a side chain. All right, so because benzene, because we only have one side chain, it's not necessary to say what number it is. So we can only say in this case, it is a methyl benzene. If we had 2 side chains, let's say we had 2 methyl groups, then it would be dimethyl benzene. But you need to give numbers now because on which carbon are the side chains. So you can say, you can start C1 from the first functional group, first side chain, and then go to the second one. So 1,2 dimethyl benzene. Okay, I will do one last example with you. So here we have another compound, and you can see that we have 2 functional groups, the same one. So, and our long chain is ethane. So we can use 1,2 ethane diol. Okay, I hope it is clear. With this, we will move on to the homework for today. I will only give you structures to name and 5 structures. So think about it, think about the rules, the side chains, the functional groups, and get to work. I will see you in my next video. Until then, please take care. Bye.